Okay, now continuing to look at equation 8 of this famous paper on GLM. Just as a reminder, the link to this paper and the complete playlist on this paper will be in the description of this video. In the previous video, we discussed this first line here of equation 8, and now we're going to move on to the second line. And yeah, this is where we're going to focus right now on this second line, and then we'll make another video that talks about these last two lines. This second line, I believe that this is a typo. This should say L, right? Because it should match right here. Second derivative of the log likelihood with respect to y. So it should be the same as that L there. So there's a Z. So, you know, if you can find that it should be a Z, please, put in the comments and we can think about it. But pretty sure that is just a typo. So let's not waste too much time thinking about it. We can go ahead, and I wrote that line here. And they wrote it as if there's no middle steps. I actually was really thrown off by this, and this took me a little bit more thought. So that's why I thought it deserved its own video, just talking about this line right here. And it's really just a combination of chain rules and product rules that get you here. So maybe it makes sense to you instantly, and that's great. But I'll go ahead and show the steps for how they got here. Okay, so first thing, let me go ahead and show the first derivative with respect to y. This can be written as dl d theta dy. Okay, so that's our chain rule. All right. So then after that, so that one's easy. You're like, okay, great. I can see how I get from here to here. Maybe you do. I need to go ahead and do the second derivative. Okay, and this is, I think it gets a little complicated because, well, you'll see. So I need to take the derivative of this with respect to the derivative of the first derivative with respect to y. Oops. Derivative d theta. Okay. Okay. So now you're seeing, okay, so basically second derivative is just the derivative of the first derivative, but with respect to y. So you're seeing the product here, and so you can kind of see how the chain rule is going to come into effect. Okay. So what is the chain rule? It's the first, okay, times the derivative of the second, my little derivative sign sometimes looks like a 2, so that's supposed to be like a d derivative. Okay, derivative of the second plus the second times the derivative of the first. Now when you take the derivative of this, you need to remember it's with regards to y. Okay, so it's this piece here that I think, that's the piece I missed the first time I was looking at this. So you just need to be careful about that. Okay, so what is this piece actually? I think it actually, let me go ahead and take this piece and maybe I'll scoot it over here. Okay. Okay. So this is, I could write this as the derivative of, so since this is second derivative, this is the same thing as the derivative of the first derivative. Okay. And the reason I wrote it like this is because now I'm going to use the chain rule again. Okay. D theta, d theta, dy. Okay. And the reason that I'm doing that is because if we look back over here, we don't have d, the derivative of the likelihood with respect to y anywhere up here. Okay. So I kind of need to get rid of that, and that's why I'm using the chain rule again. Okay. So you see I've broken it up again. Okay, so now since I'm finding a derivative of a product, guess what, guys? That's chain rule, or that's a product rule again. So you see how it's a little bit confusing. So let's do product. So derivative of the first, or well, it doesn't matter what order you go in. So the derivative of the first times the second, plus the second, or wait, let me not confuse myself. The derivative of the first times the second, plus the first times the derivative of the second. All right, and note I'm taking the derivative with regards to theta right now. Okay, so that's not dy squared, but it's d theta dy. Okay. So you have to be really careful when you're doing that product rule that you're making sure you're doing the derivative of the correct thing. Okay, so now there's going to be a nice cancellation here. So let's think about this. I'll leave this alone for right now. I want to talk about this back piece back here. Okay, this is the same thing as writing the derivative with respect to y of d theta. Okay, why is that? Well, right, a second derivative is just the derivative of the first, and I've just rearranged the order of my the order of taking the derivative, which you're allowed to do under some conditions. So this basically becomes 1. And what's the derivative of 1 with respect to y? Well, the derivative of a constant is always 0. So that basically means this whole thing will go to 0. Okay, so I'll be left with this front piece right here. So let's plug that in. Okay, I'm just going to write it right underneath of this. So dl, the second derivative of the log likelihood, d theta dy. Okay, so that's this piece here. So let me just go and scroll over. Okay, I'll change back to yellow. Okay, we notice that this one and this one are the same, so they can be written as a square. Okay, second derivative of log likelihood with respect to theta, and then the first derivative with respect to y squared. Okay, and if we look back at what we had originally, they're the same, right? Just the sum is written in the other direction, but basically it's exactly the same thing. So there we go. We showed that first line there. So not too hard, but it does take some work, and it takes using the product rule twice. Okay, so you need to be a little careful about that. Okay, so then in the next video, we'll go ahead and finish up equation 8.